Hello and welcome to lesson 2.5. Today we're going to talk about finding probabilities using tables. And a contingency table, or sometimes we just say a table, is just one way to organize our information. Let's think back for just a moment to what we know about Venn diagrams. And if you remember a Venn diagram, they compare two and sometimes more than two, sometimes we might have three circles, but for the most part we've seen Venn diagrams that compare two things. So for example, here we have an A and a B, and we read this by saying that there are 30 items that fit into both A and B. There are 23 items that will fit into only A, which means that altogether A will have a total of 53 items in it. And we can do the same for B. If there are 27 things that are only in B, when we add up all of the numbers that are within this circle for B, we'll find that there's actually 57 things that fit into B. Just 30 of them happen to also be a part of A. So if we wanted to ask a question about our probabilities from our Venn diagram, if we asked for the probability of A and B, then what we're looking for really is the probability that both will happen. And in that case, we'd look where the two circles overlap or intersect, and we'd find that there were 30 things in both A and B out of our grand total, which happens to be 100. Likewise, if I asked about the probability of A or B in a Venn diagram, we would add up all of the things in A and B and also both. In other words, we'd say 23 plus 30 plus 27. We would add those numbers together and we would get 80 out of 100 for that probability. So in a Venn diagram, if I say A or B, I add up all the numbers that fit into any of those categories. And if I say A and B, well, that's when I'm just going to focus on whatever happens to be in the center. And so if we remember how a Venn diagram works, when we look at a table, we'll find that the way we find a probability from a table is almost exactly like finding from a Venn diagram. What we need to remember, though, is that a table will show us more information than a Venn diagram can. If we used a Venn diagram to show the information here about students in their grade level and how they get to school, we would have probably easily 6 circles overlapping. That would just be a mess. So instead, we're going to use a table, and the way we find our probabilities from a table is almost identical to how we find them using a Venn diagram. The first step for finding a probability using a table is to first get all of the row and column totals, and you'll see here that I've totaled them up in blue, and then we also need a grand total. So when we add either 210 plus 290, we should get 500, and just as a double check, when I add together these bottom numbers, I should also get 500. That's how I know that I added them correctly. So here is my grand total, 500. And now I'm ready to answer some questions. Number 1 says, find the probability that if I randomly select a student, if we're looking for the probability of a 9th or 10th grader, and then remember this symbol means or, someone who is in 9th or 10th grade or rides a bus, what I'm going to do is I'm going to go up to my table and I'm going to find all of the people that are 9th or 10th graders. So that's these people, these people, these people, and these people. Those are my 9th or 10th graders. And then remember, or means we're going to add up anybody who's in either category and then also anybody who does both. So I'm going to go now to my bus riders, and I've already circled the 106 here. I'm only going to circle the 41. I have 5 numbers circled, and now what I'm going to do is add up those people. And when I add up all the circled numbers, I get 251 students out of my grand total of 500. And of course I can change that to a percent anytime I want. Number 2 asks for the probability that I'll randomly select someone who is a walker. To find the probability of a walker, I'm going to go to my table and I'll circle anyone who walks. So those 2 circled numbers are walkers, and so I can say that 88 out of 500 is the probability that I'll find a walker. To find the probability that someone is not a bus rider, well, that's anyone who walks, so these people, anyone who takes a car, and anyone who gets to school in some other way. And I can either add up those 6 numbers, or I can use my totals if I want down at the bottom, the 88, the 254, and the 11. Either way, I should come up with 353 out of 500 is the probability that I will select someone who is not a bus rider. And finally, the last one asks for the probability that you will select someone that is a 9th or 10th grader and that they ride the bus. Well, remember, in a Venn diagram, if I want the probability of A and B, that's where they overlap. That's the center. Well, the same thing is true for a table. So I'm going to find where the 9th or 10th graders are that ride the bus. These are 9th or 10th graders and they ride the bus. There's 106 out of 500 is my probability. Now we want to talk about conditional probability. Conditional probability is expressed using the language A given B. And what this means is we only are concerned with whatever is in event B. So whatever follows that line, this is our notation, this vertical line here means A given that B is definitely going to happen. So for example, if I ask the class to stand up, if you're a 10th grader, given that you're a girl, I am only concerned with girls in the class. So what I'll do is I'll count all the girls, and then out of just the girls, I would want to know who is a 10th grader. That's what it means to have that condition. It's conditional that you must be a girl. And in the second example, stand up if you are a boy, given that you are a junior. I am only concerned with juniors in class. So I'll count up all the juniors, and out of those juniors, I want to know who is a boy. So conditional probability gives the condition that B is definitely going to happen. I'm only concerned with events in B. So for example, number 5 says, find the probability that I will select a student who drives a car given that they are an 11th or 12th grader. So I'm going to come up to my table, and it must be an 11th or 12th grade student. So I'm going to circle that row. Sometimes it's a row, sometimes it's a column. Whatever follows that vertical line, that is who I am concerned with. So out of my 290, that's the total 11th and 12th graders, out of that 290, I want to know who drives a car. Well, there happens to be 184 students who drive a car. So my probability is 184 out of 290. Number 6 asks for the probability that I will select a 9th or 10th grader given that they ride the bus. So again, I'm only concerned with whatever's given. That's my condition. They have to ride the bus. So I'm going to circle this time a column of bus riders. And there happen to be 147 bus riders. And out of those 147 bus riders, 106 are 9th or 10th graders. And the last one, number 7, asks for the probability that I will randomly select someone who takes the bus given that they are an 11th or 12th grader. So again, it's given that they're an 11th or 12th grader. So I'm going to circle the 11th or 12th graders because that's who I care about. So out of 290, how many of them take the bus? 41. So 41 out of 290 is my probability. Now, using this table, what I'd like you to do is try a couple of these on your own. We're going to pause this video, allow you to work on A and B by yourself, and try them out, and then when the video is unpaused, we'll see the answers on the screen. So go ahead and pause the video right now. So question A asks for the probability that a student is a 9th grader or involved in athletics. So again, it says or. I'm going to circle anyone who's a 9th grader and anyone who's involved in athletics, and those are the students that I'm going to add together. And so my grand total is 1625, and so out of those 1625, 800 of them are either a 9th grader or involved in athletics. And then question B asks for the probability that a student is a senior and involved in nothing. Well, that's going to be these 150 students out of 1625. So check those answers, see if you got them right. And again, here are the last two questions to try on your own. Go ahead and pause this video right now and try C and D all by yourself. So C asks for the probability that a student is involved in fine arts given that they are a junior. So this is a probability that is conditional. So given that they're a junior, I'm going to come and circle my juniors. So out of my 410 juniors, the probability that they're involved in fine arts would be 70 out of 410. And then question D is similar. Given that the student is a 10th grader, so I'm going to circle the 10th graders. So out of my 390 10th graders, the probability that a student is involved in athletics is 160 out of 390. So check those problems and see how you did.
Made with Doodlecast Pro.